you, Laura. Okay, I'm gonna hide this again. All right. So we're gonna start with the Florence kit, as Nigel was saying. This is one of the three kits that we developed in the latest months uh, to help you with starting with the XR and AI integrations with camera access. We tried to cover some common scenarios that we thought about. That's why we implemented zero shot object detection, which is something like this, where you can kind of take a snapshot of scene, um, and then AI can understand and can give you like bounding boxes or like positions of objects, um, that you can then position in the 3D space. Um, Now, of course, this model was made for 2D, right? 2D images or 2D video. So what we are providing you also here in this kits is the ways where you can transform this information from 2D to 3D, right? Which is the other big part of like this all these implementations. It's also always like a two-part thing, right? It's like first you want to be able to run your model in Unity or on the engine you're using, um, but then all these models usually work in 2D, so then you need to convert this to 3D. So it's usually like this two-part thing. Um, so here, yeah, we have made a pass-through camera access, Florence 2 in this case, and then we're just placing these labels in space, right? Florence 2 is again, is like a zero-shot model is called, where it was just trained and a lot of data, so it allows it to just kind of just interpret the scene without looking for any particular thing. Um, and the implementation in Unity that we have is here. You'll look at a scene like this in the repo that was shared. So there's one thing that I noticed in the last few days is that I'm using NVIDIA platform for the inference for the models. So it's hosted models in NVIDIA servers. Um, and you can check what they have on their platform called Build. So you go to build.nvidia, um, and well, this is the thing I noticed that Florence 2 was missing. And then I realized they replaced it with a different model called Grounding Dino, um, which is another zero shot model. So what I did is implementing this model also in this kit now. So now if you go to the repo, well, I'm gonna update it like after this workshop, but you're gonna go to the repo and there's gonna be two controllers basically. There's a Florence 2 and there's a grounding Dino controller. It's essentially the same. They're both zero-shot models that return a bounding box. So if I run it, um, I can get a bounding box out of an image, right? There is a difference though with grounding Dino, where grounding Dino wants like it is more smart, I found, but it wants a prompt. So you want to be searching for something in particular. So in this case, I can just write bike, and I can send a request that uploads the image to the server, and returns the bounding box, right? Bike with a 0.72 certainty. Um, so in this project, you will find these controllers that they do all the connection, all all the process of sending an image, sending it to like getting the image, sending it to NVIDIA server, getting the answers, and then we have two options here essentially, two anchor modes, which are bonding box. That is what I'm trying out here. But then when you want to build for the headset, you can change it to spatial label, which is more like what we see in this animation, in this GIF, right? In this video we saw earlier. And that transformation is happening here within the controller. And that's what is more interesting, in my opinion. Like the model implementations are like just standard to like any platform. There's no difference in sending an image from a web app, that sending it from Unity is still is a web request, is a REST API, so that doesn't change. But what it changes in this case is here, this method here, this coroutine that I have here, that
We all see the presentation, not for your monitor.
oh, I see. Sorry, what do you see right now?
The presentation, what are we looking at? The slide.
Oh, okay. Let me.
There's a notification on the top of the display saying, please move this window away from the shared application.
Yeah.
Now something is moving.
Oh, yeah. Trying to find the controls. They always get hidden somewhere. Can you take over my yeah, I'm gonna share again. I think I was just sharing the one application instead of sharing the whole thing. Can you see Unity now?
Now we can see it, yes.
Can you see Unity? Sorry, what do you see?
We see Unity, yeah, no, yes.
Okay, you see Unity now. And the code.
Yeah.
Okay, thank you. All right, so yeah, what I was saying. Oh yeah, I closed the project. Zero shot. Yeah, the AI implementation is standard. It's a REST API. It has certain specific things that depending like on the model, but they're all documented usually here and in the samples of NVIDIA or in any platform. They usually put some examples on how to parse this data and all that. But it's what is interesting is what we're doing in the case we're doing the 3D anchors, right? Like if we go here to the controller and then set it to spatial labels, which is what we want in XR. Like you want maybe to position something in space, right? Not flatten an image. And what is happening there is I have like this diagram trying to explain what happens. Just imagine this scene here is like my room, right? I have a table here with some elements, and this is me with my headset. And the model essentially takes an image of what I'm seeing, a flat image that comes from the camera pass-through, right? And it sends it to the model. It takes an image that looks like this, right? It's more like flat. It's a 2D image. It's like a capture of what I'm seeing. Um, and then the model will return these bounding boxes, right? Um, with different with the different positions within the 2D image of these elements. But how we position them in 3D is that once we have, for example, okay, this chest is here, is in the pixel or is in the middle of the image, right? A bit beneath the center on the vertical, because the bounding box will have these coordinates, like where it is within this bigger image. When we have that information, what we can do is what is called a raycast from the headset, a depth raycast that goes from your camera to the center of the subject, and it extends until it hits the real thing in your space. Um, and that's done with depth because you see you have this image in front of you. Shows a laptop in my case. But then when we have the position of this laptop in this 2D image, I can just cast this ray and I can kind of anchor it into a real position in the scene. Um, that's how here in this video, things are being anchored, right? I take this snapshot, I get these bounding boxes, and then I shoot all these rays that make all these 2D bounding boxes kind of go to the 3D space. So that's the part that is kind of new for XR, right? If you were familiar with AI models before in any other medium, that kind of changes a bit in XR because you're in a 3D world, right? And in this case, that's happening here in this function, this playground in Dino results. In this case, in this controller, where we have the data here in these bounding boxes. We turn it into something that we can use. And then in this spawn detection visuals, if we go to the anchor mode spatial label, we can see here that we're using these pass-through camera utils that has this method called screen point ray in world, screen point to ray in world, which is the one that is doing this, like shooting a ray that goes through a point in this image and getting the result, like where this point where this hit was. So when we have that hit info point, we can say, okay, let's add this anchor at that position. And that what is called anchor in that case is one of these labels, right? So this little sphere, there goes where this ray hits. But yeah, that's I think what is interesting here. What is probably gonna be something you spend some time in the hackathon if you are gonna go with AI vision models. It's gonna be one of the critical points, like how you use this data in the space. But yeah, here in this kit and the other kits, you can find examples on how to do that, and instructions on how to set them up. In this case, as I said, this kit now is using grounding Dino as the main one, at least until I figure out where NVIDIA put the Florence 2. or if it's a permanent thing that they removed it from the platform. But in the meantime, you can try the grounding Dino model, which is a bit slower, but it's a bit smarter. So, for example, what is interesting I found is that, just quickly before we move to the next one, that if I have a picture like this, for example, um, I can I can not only like ask for like an object or like certain like more generic tag. I can also say something like tallest cat, um, and let me just play the Unity scene. And you can also use prompt array of things. So I can prompt tallest cat, shortest cat, like separated by commas. Uh, Send the request, um, and it will return this one as the tallest cat, this one as the shortest cat. So there's definitely like more reasoning happening in this model, but also a bit slower than Florence 2 I found. But in the other hand, we have the RoboFlow implementation that Nigel is gonna go over. That is definitely very fast if you're looking for like speed. So in this case, grounding Dino comes as like a more like a intelligent one. If you wanna really like ask for like this kind of like questions, more like in your space, like uh, like let's look for the most bright area of my room, the most dangerous place of this room to, like that kind of things. I think is interesting, um, because they can kind of analyze and decide these kind of things. So I thought it was quite interesting. But yeah, the kit link is shared already. I'm gonna push this right now with this other model implementation, but the instructions for setting up remains the same. It's just that you're using this controller instead of that other one there. So yeah, that's it for this kit, the zero shot kit. I will call it now instead of just Florence 2, because now we have two zero shot implementations there. So I'm also renaming it. But yeah, I think we can continue with the RoboFlow kit.